Hello there, and welcome to The Sleepy Scholar. Tonight's journey takes us into the ancient, glowing world of fire. It is a companion that has sat with humanity since our very first memories. Before we had words, we had the glow of the flame. It is a process, a dance of chemistry that patiently waits, locked inside wood and fuel, waiting for the invitation of a spark. When it arrives, it does not destroy, but rather transforms. It unwraps the energy that the sun gifted to a tree, releasing it back into the night as warmth and light. Fire is the universe's great recycler, a fleeting spectacle of release. It is the steady glow in the hearth, a soft beacon against the dark, and a force that has quietly shaped our world in countless ways. We often think of fire as a small thing, a candle flame or a campfire. But it is also the engine of the stars. The sun itself is a magnificent ongoing firestorm, a nuclear furnace whose light travels across the void to warm our world. In this journey, we will explore this gentle paradox. We will look at the quiet science of combustion, the history of how this force became our partner, and the gentle, steady glow that it casts across our understanding of the universe. If you enjoy these quiet explorations, consider subscribing so you can easily return here whenever you need to rest. For now, get comfortable. Let your eyes grow heavy. Let's begin. Fire is not a substance, but a chemical event that requires three specific elements to exist. We often speak of fire as if it were a thing like water or stone. But you cannot hold fire. You cannot store it in a jar. This is because it is not an object, but a process, a rapid transformation happening in real time. It is the visible, tangible result of a chemical reaction. This event is often visualized as the fire triangle, a simple, elegant model of its needs. The three sides are fuel, heat, and oxygen. The fuel is any combustible material, the potential energy sleeping in wood, gas, or cloth. The heat is the activation energy, the spark or friction that raises the fuel to its ignition temperature. And the oxygen is the oxidizer, the element that eagerly combines with the fuel, breaking it apart and releasing its energy. If you remove any one of these three patient pillars, the entire structure of the fire gently collapses. The flame cannot be sustained. This triangle is a perfect, fragile balance. It is the story of energy's release, a fleeting moment where matter is converted into light and warmth, all held together by a simple three-part harmony. The color of a flame reveals a precise story about its temperature. When we gaze into a fire, we see a dance of light, a spectrum of yellows, oranges, and reds. These colors are not random. They are a direct language, a visual signal of how much energy is being released. It is the fire's way of telling us how intensely it is working. The coolest part of a flame, often seen where the fuel is just beginning to combust, glows red at temperatures around 1100 to 1800 degrees Fahrenheit, or 600 to 1000 degrees Celsius. As the fire draws in more oxygen and combustion becomes more efficient, the colors shift. The familiar bright yellow and orange of a candle or a campfire sit in the middle, hotter still. But the most intense, efficient flames burn with a pale blue or even white light. This blue light, often seen at the base of a gas stove's flame, indicates complete combustion and can reach temperatures over 2600 degrees Fahrenheit or 1400 degrees Celsius. The flame, therefore, paints a portrait of its own invisible energies, using a palette that ranges from the gentle ember red to the fierce, almost silent blue of perfect transformation. Our ancient ancestors Homo erectus, likely began to control fire around 1.5 million years ago. Long before our species, Homo sapiens, walked the earth, another hominid ancestor was making a monumental discovery. In the savannas of Africa, Homo erectus lived in a world of profound natural forces. They faced predators, cold nights, and the limitations of raw food, but a shift was coming. Evidence found at sites like Wonderwork Cave in South Africa shows traces of burnt bone and plant matter in layers far too deep to be modern. This suggests that these early humans were not just harvesting fire from natural events, like lightning strikes, but actively maintaining and using it. This control was a profound turning point. Fire offered warmth, extending life into cold regions. It provided a guardian light, keeping nocturnal predators at bay, and most importantly, it allowed them to cook their food, unlocking nutrients and making digestion easier. This was perhaps the first great partnership between humanity and a natural force. The hearth became the center of social life, a point of light around which safety, community, and a new kind of future could begin to form. Smoke is not a gas, but a collection of tiny unburned particles floating in the air. Where there is fire, there is almost always smoke. We see it as a grey or black cloud, rising and drifting on the breeze. It seems ethereal, like the ghost of the flame itself. But smoke is a physical substance, a cloud of evidence telling a story of imperfection. In a truly perfect, efficient fire, all the fuel would be converted into just carbon dioxide and water vapor, both of which are invisible. But most fires are not perfect. Smoke is the consequence of incomplete combustion. It is a dense aerosol composed of minuscule solid and liquid particles. These are tiny, unburned fragments of the fuel, particles of soot, tar, oils, and ash. When you smell wood smoke, you are smelling these microscopic bits of carbon and complex organic compounds released from the wood, which failed to be consumed by the flames. Smoke, then, is the part of the fuel that escaped transformation. It is the story's remainder, a visible sigh of particles that the fire could not fully embrace, set free to wander the air. Wildfires can create their own weather systems, allowing them to move at astonishing speeds. A wildfire is not just a large campfire. It is a living, breathing entity with a terrifying appetite, capable of consuming vast landscapes. Its behavior is complex, driven by fuel, terrain, and the air itself. A fire of this magnitude releases an immense column of superheated air, which rises rapidly. This creates a low-pressure area at its base, pulling in cooler air from all sides in a powerful indraft. This new oxygen feeds the flames, creating a cycle of escalating intensity. This process can form pyrocumulus clouds, or fire clouds, which can generate their own lightning and powerful erratic winds. Driven by these self-made gales, a wildfire can spot, tossing burning embers more than a mile, or about 1.6 kilometers ahead of the main fire front. This allows it to leap over rivers and highways, moving not by slowly creeping, but by jumping across the land at speeds that can outpace a running human. This is fire acting on a truly majestic scale, a force that no longer just follows the wind, but begins to conduct the sky itself. The upward draft in a chimney is created by a simple, elegant principle of physics known as the stack effect. For centuries, the fireplace has been the warm heart of the home, but its function relies on a hidden engine, a gentle but persistent force that pulls smoke up and away, keeping the room clear. This invisible movement is a quiet demonstration of thermodynamics. This phenomenon, also called the stack effect, is born from the difference in density between hot and cold air. The fire in the hearth heats the air directly above it, causing it to expand and become much lighter, or less dense, than the cooler, heavier air in the rest of the room. This column of hot, buoyant air begins to rise, moving up the chimney flue. As it rises, it creates a subtle vacuum, a negative pressure at the base of the chimney. This vacuum, in turn, gently pulls fresh, oxygen-rich air from the room into the fireplace, feeding the flames and ensuring the cycle continues. The chimney is therefore a passive engine, a vertical river of air, guided only by the fundamental desire of warmth to rise and the cold to descend. Ancient Greek mythology tells of the Titan Prometheus, who stole fire from the gods and gave it to humanity. In the ancient world, fire was seen as a divine power, a piece of the sun itself, belonging only to the gods on Mount Olympus. Humanity, in this time, lived a simpler, harder life, lacking the tools of civilization. The gods, particularly Zeus, intended to keep this power for themselves. The Titan Prometheus, however, saw the potential sleeping within mortals. Believing in them, he defied the gods. According to the myth, he traveled to Olympus and stole an ember, a glowing coal, from the forge of Hephaestus, the god of fire and craft. He concealed this divine spark inside the hollow stalk of a fennel plant and carried it down to earth, presenting it to the first humans. With this gift, humanity learned to cook, to forge metal, to create art, and to light the darkness. For this act of profound generosity, Prometheus was punished severely by Zeus, but his gift had already changed the world. This story is not about history, but about a deeper truth. It represents the moment that fire ceased to be just a natural terror and became a tool, a technology, and the very spark of human ingenuity and enlightenment. Many of the world's ecosystems are not just adapted to fire, but are entirely dependent on it for their health. We are often taught to see fire as a purely destructive force, an enemy of the forest. We picture the loss of trees and the flight of animals. But in the grand, slow rhythm of nature, fire is not an end. It is a vital and necessary agent of renewal. In ecosystems like the pine forests of North America or the savannas of Africa, fire is a recurring, natural event. These landscapes are fire adapted. Some species, like the giant sequoia, have bark that is incredibly thick, sometimes up to 2 feet, or over half a meter, insulating the living tree from the heat. Other trees, like the lodgepole pine, have cones that are sealed shut with a strong resin. These serotinous cones will only open to release their seeds when they are exposed to the intense heat of a fire. The fire clears the forest floor of brush, returns nutrients to the soil, and opens the canopy, allowing sunlight to reach the new seedlings. In these places, fire is the great gardener. It is the reset button, the force that clears away the old to make way for the new, ensuring the forest's long and patient continuation. Spontaneous combustion is a real phenomenon, where an object can burst into flame without any external spark. It sounds like something from a fantasy, a sudden, impossible fire blooming from nowhere. But this strange event is a quiet reality, born not from magic, but from a slow, patient buildup of internal heat. It is a fire that starts from within. This process, known as spontaneous ignition, requires a few key ingredients. It typically happens in piles of organic material, such as oily rags, compost heaps, or damp hay bales. The process begins with slow oxidation, a chemical reaction that generates a small amount of heat. If this material is piled thickly, it acts as its own insulator. Trapping this heat, the rising temperature speeds up the oxidation, which in turn generates even more heat. A vicious cycle begins. Over days or weeks, this internal temperature can slowly climb, unseen, until it finally reaches the material's auto-ignition point. At that moment, the object appears to suddenly catch fire, though the fire itself has been building in slow motion all along. It is a reminder that fire is a process of energy release, and sometimes that process can begin in a whisper, building its strength in the dark before it finally announces itself in flame. The mythical phoenix is a bird that is cyclically reborn from the ashes of a fire it builds for itself. Across many ancient cultures, from Egypt to Greece, a powerful story was told. It was the legend of a magnificent bird, adorned with plumage of gold and scarlet, which lived for centuries. Its life was not like other creatures. It was tied directly to the transformative power of flame. As the phoenix grew old, nearing the end of its long life, it would build a nest for itself, not from mud or twigs, but from the most fragrant and aromatic spices like myrrh and cinnamon. It would then settle upon this nest and, using the power of the sun or its own internal fire, ignite the spices. The bird would be consumed completely in a brilliant, fragrant blaze, leaving behind nothing but a small pile of fine ash. But from these very ashes, a new, young phoenix would emerge, reborn, to live its long life once more. This enduring myth captures our deepest understanding of fire. It is not just an end, but a transformation. It is the symbol of renewal, resilience, and the beautiful, certain idea that even from complete endings, new beginnings can arise. Bioluminescence is often called cold fire because it produces light without generating any significant heat. Not all light comes from the fiery, energetic release of combustion deep in the ocean or in the soft darkness of a forest floor. Nature has found another way to glow. It is a living light, a chemical shimmer that defies the heat of a normal flame. This phenomenon is a chemical reaction, not a thermal one. It involves two key substances, a molecule called luciferin, which is the fuel, and an enzyme called luciferase, which is the spark. When luciferase interacts with luciferin in the presence of oxygen, it catalyzes a reaction that releases energy in the form of a photon, a single particle of light. Unlike a burning candle, where most energy is lost as heat, this process is incredibly efficient. Nearly all the energy is converted directly into light. This is why a firefly flashing in the summer night, or a deep-sea creature illuminating the abyss, remains perfectly cool to the touch. It is nature's own magic trick, a gentle, silent fire that illuminates the darkness without burning, a testament to the diverse and inventive pathways of life. Although it provides our world with heat and light, the sun is not technically on fire in the way we understand combustion. We look at the sun, our magnificent star, and instinctively call it a ball of fire. It shines with unimaginable brightness, and its heat travels 93 million miles, or 150 million kilometers, to warm our skin. It seems like the ultimate bonfire. But the fire we know on Earth, the fire triangle of fuel, heat, and oxygen, cannot exist in space. The sun's energy comes from a far more powerful and fundamental process, nuclear fusion. Deep in the sun's core, the pressure and temperature are so immense that hydrogen atoms are squeezed together. They overcome their natural repulsion and fuse, merging to form helium. This act of fusion releases a tiny amount of matter as a tremendous burst of energy, As described by Einstein's famous equation, this energy, in the form of gamma rays, slowly makes its way to the sun's surface over thousands of years before finally leaping into space as the light we see. The sun, then, is not burning. It is transforming matter itself, a celestial furnace whose glow is not a chemical reaction, but the very birth of new elements. The familiar crackling sound of a wood fire is not the sound of the fire itself, but of trapped water and gases exploding. One of the most comforting sounds is the gentle pop and crackle of a log fire. It seems to be the very voice of the flame, a soft percussion accompanying the dance of light. But the fire itself is relatively silent. What we are hearing is the sound of the fuel's transformation. Wood, even when it appears dry, is filled with tiny microscopic pockets of trapped water and tree sap. As the fire heats the log, this trapped moisture boils long before the wood itself ignites. The water turns to steam, expanding rapidly to over 1,000 times its original volume. This high-pressure steam becomes trapped within the wood's cellular structure. Eventually, the pressure becomes too great, and the small pocket of wood bursts open with a sharp pop or crackle to release the steam. We are not hearing the fire. We are hearing a series of miniature contained explosions, the sound of the wood's internal world being released. This gentle, crackling song is the sound of tension and release, the audible story of water's escape from the embrace of the wood. The Great Fire of London in 1666 devastated the city, but it also had the unintended consequence of ending a plague. In the 17th century, London was a medieval city, a crowded labyrinth of narrow streets, wooden houses, and thatched roofs. It was a place highly vulnerable to fire, and in 1665, it had been ravaged by the Great Plague. The fire began in a bakery on Pudding Lane in the early hours of September 2nd. It spread with terrifying speed, fanned by strong winds. For 4 days, the firestorm consumed the city, destroying over 13,000 houses and 87 churches, including the great St. Paul's Cathedral. While the human toll of the fire itself was recorded as being remarkably low, the blaze had a profound, unforeseen effect. The intense heat and flames scoured the overcrowded, unsanitary slums where the plague had thrived. It is believed to have incinerated the rats and fleas that carried the disease, effectively sterilizing the city center. Out of this immense destruction, the city was reborn. The fire cleared the way for a new London, one built of brick and stone with wider streets, and one remarkably free of the great sickness that had haunted it for so long. Modern firefighter turnout gear protects from extreme heat, not by cooling, but by using layers of specialized insulation. Firefighters must walk into environments where temperatures can reach 1,000 degrees Fahrenheit or over 500 degrees Celsius in an instant. To survive this, they wear sophisticated multi-layered suits often called bunker gear. This gear is a marvel of material science, designed to manage heat in 3 distinct ways. The outermost shell is made of a material like Kevlar, which is flame resistant and tough enough to resist tearing. Just beneath this is a moisture barrier, a layer that keeps hot water and steam from reaching the firefighter's skin. The most critical part, however, is the thermal liner. This is a thick, quilted layer of insulating, non-flammable material. It doesn't stop the heat, but rather slows down its transfer, trapping air in its fibers. This creates a buffer, giving the firefighter precious minutes to work before the intense heat begins to penetrate. This suit is a personal fortress, a wearable technology that allows a human to briefly step into a place of impossible heat, armed not with immunity, but with borrowed time. The ash left behind by a fire is the collection of incombustible minerals that the flame could not transform. After a fire has moved on, after the wood has been consumed and the flames have died, a soft, grey powder remains. This is ash, the final residue of the fire's great work. It is the part of the fuel that the fire could not use. While the fire releases the wood's stored carbon and hydrogen as gas and light, it leaves behind the heavier mineral elements that the tree drew from the soil. Ash is composed primarily of these minerals: calcium, potassium, magnesium, and phosphorus. These are the same nutrients that plants use to grow. In a forest, this ash is a powerful natural fertilizer. When rain washes the ash into the ground, it replenishes the soil, providing the perfect nutrient-rich bed for new seeds to take root. This is a critical part of the cycle of renewal, the fire's final gift back to the earth. Ash is not an ending, but a return. It is the mineral memory of the tree, patiently waiting to be woven back into the fabric of the forest, ready to begin the long, slow climb toward the sun once more. In the zero-gravity environment of space, a candle flame burns in the shape of a sphere. On Earth, we are surrounded by an invisible ocean of air and a force called gravity that gives it weight. This gravity is responsible for the teardrop shape of a candle flame. It is a shape so familiar, we assume it is the only one a flame can have. The tall, flickering shape is a product of convection. The flame heats the air around it, which becomes less dense and rises. Gravity pulls the cooler, denser air down to replace it, creating a constant upward flow that draws the flame into its characteristic point. But in microgravity, on the International Space Station, for example, this up and down does not exist. The hot air does not rise. Instead, the flame pushes its spent gases and heat outward in all directions equally. Fresh oxygen must slowly diffuse in from all sides. The result is a simple, stable, and beautiful sphere of light, a tiny blue glowing bead that is much dimmer than its earthly counterpart. This tiny spherical flame is a perfect illustration of the profound unseen forces that shape our world, revealing the invisible hand of gravity in the simple flicker of a candle. In ancient Rome, a sacred, perpetually burning fire was tended by a group of priestesses known as the Vestal Virgins. In the heart of the Roman Forum stood the Temple of Vesta, the goddess of the hearth, home, and family. This was not a temple that held a statue of the goddess, but rather it housed her living symbol, a sacred flame, which was believed to be a reflection of the city's vitality. This fire was never allowed to go out, as its extinguishment was thought to foretell the fall of Rome itself. The immense responsibility of tending this eternal flame was given to the Vestals. These women were chosen as young girls and served for 30 years, bound by a strict vow of celibacy. They were among the most powerful and respected women in Rome, free from the usual social obligations, with unique legal privileges. Day and night, in shifts, they watched the fire, ensuring it was fed, cleaned, and protected. If the fire did go out, it was considered a national catastrophe. This sacred duty demonstrates the profound importance the ancient world placed on fire, seeing it not just as a tool, but as the living, breathing heart of their society's endurance. Rust is a form of fire, a very slow and steady process of oxidation happening over years. When we think of fire, we imagine a rapid, hot, and bright event. We see the flames and feel the heat of combustion. But the chemistry at the heart of fire, oxidation, also happens in quieter, slower forms. Oxidation is simply the process of a substance losing electrons, often by combining with oxygen. When wood burns, it oxidizes quickly, releasing all its energy as heat and light in a matter of hours. Rusting is the very same chemical process, but happening at a glacial pace. When iron is exposed to oxygen and water, the iron atoms slowly combine with oxygen, creating iron oxide, which we call rust. This reaction also releases heat, just like a wood fire, but it does so over such a long period, months or years, that the heat is undetectable, dissipating into the environment as it is created rust. Then is the gentle, invisible burning of metal. It is a slow motion fire, a patient transformation that reminds us that the same chemical dance that creates a bonfire also quietly dissolves the strongest steel. A fire piston is an ancient tool that creates fire by rapidly compressing air. Long before matches or lighters, humans discovered an ingenious way to create an ember, using only the physics of air itself. This remarkable device, found in Southeast Asia and the Pacific Islands, is a testament to an elegant understanding of thermodynamics. The fire piston consists of two parts: a hollow, sealed cylinder and a piston that fits snugly inside it. A small piece of tinder, like dry fungus or char cloth, is placed at the end of the piston. The user then slams the piston down into the cylinder with a single, rapid, forceful motion. This sudden, extreme compression of the air inside the cylinder causes its temperature to skyrocket, following the ideal gas law. For a split second, the air temperature can exceed 800 degrees Fahrenheit or 400 degrees Celsius, which is well above the ignition point of the tinder. The user immediately pulls the piston back, revealing a glowing, perfect ember. This tool is a magnificent piece of captured lightning, a way of harnessing the invisible heat hidden within the air, creating a spark from nothing but pressure and speed. The sun's atmosphere, the corona, is paradoxically millions of degrees hotter than its visible surface. It is one of the greatest mysteries of our star. The surface we see, the photosphere, glows at a temperature of about 10,000 degrees Fahrenheit or 5,500 degrees Celsius. Yet the corona, the sun's ethereal outer atmosphere, which stretches millions of miles into space, sizzles at temperatures exceeding 1.8 million degrees Fahrenheit or 1 million degrees Celsius. This defies all intuition. It is like a fire being cooler than the air a few feet away from it. Scientists are still exploring the exact mechanism for this coronal heating problem. The leading theories involve the sun's incredibly complex magnetic fields. These fields are thought to constantly twist, snap, and reconnect, creating nanoflares, which are billions of tiny, continuous explosions. Another theory suggests that energy waves from the sun's interior, called magnetohydrodynamic waves, ripple up into the corona, vibrating and releasing their energy as heat. The sun's atmosphere remains a place of profound and beautiful mystery, a halo of impossible heat, held in place by invisible forces. The hottest known fire in the natural universe is not a chemical flame, but the light from a gamma-ray burst. The fires we know on Earth are gentle chemical reactions, limited by the energy stored in chemical bonds. But the universe holds fires of a different order, born from the most extreme events. Gamma-ray bursts are the most luminous and energetic explosions known. They are thought to be caused by the collapse of a massive star into a black hole, or the collision of two ultra-dense neutron stars. In these cataclysmic moments, jets of material are blasted out at nearly the speed of light. The particles within these jets collide, creating an unimaginable fireball of pure energy. This is not chemical combustion. It is a fire of fundamental particles and high-energy photons, a relativistic inferno where temperatures can reach a trillion degrees. These bursts release more energy in 10 seconds than our Sun will in its entire 10 billion year lifetime. They are the true ultimate fire, a brief, terrifying, and majestic announcement of creation and destruction on a cosmic scale, a flash of light visible from the very edge of the observable universe. The original Olympic flame was a sacred fire kept burning at the altar of Zeus during the ancient games in Greece. The modern tradition of the Olympic torch relay is a beautiful echo of a practice that is thousands of years old for the ancient Greeks. Fire was a divine element, a connection to the gods. During the Olympic Games, which were a religious festival as much as an athletic one, a fire was lit at the sanctuary of Hestia, the goddess of the hearth. But the most prominent flame burned at the altar of Zeus, the king of the gods, in whose honor the games were held. This fire was kindled using a special mirror called a scaphia, a curved disc that focused the sun's pure rays, ensuring the flame was of divine origin. Untouched by human hands, this flame would burn continuously for the entire duration of the festival. This sacred fire was not relayed from place to place. It was a stationary beacon, a symbol of the divine presence and blessing upon the games, a pure celestial light watching over the human contest below. In 1962, a coal seam fire was accidentally ignited in the town of Centralia, Pennsylvania, and it has been burning ever since. Beneath the small, quiet mining town, a vast, labyrinthine network of anthracite coal mines lay abandoned. In May of that year, a fire was lit to burn trash in a landfill, but it was not properly extinguished. The fire found its way into this network of tunnels, igniting a rich seam of coal, and it did not stop. For over 6 decades, this fire has been slowly, relentlessly moving through the underground veins of fuel. It is a fire that cannot be easily extinguished. It is too deep, too vast, and has an almost endless supply of fuel and oxygen from the interconnected tunnels. Over the years, the ground opened up, releasing toxic smoke, and the earth became unstable, forcing the town's evacuation. Today, Centralia is a ghost town, with empty streets and smoke still venting from cracks in the earth. It is a quiet, slow-motion disaster, a fire that has outlived the community that started it, a sleeping giant of combustion that continues its patient underground journey. The concept of a phoenix down in video games is likely inspired by the mythical bird's ability to be reborn from its ashes. In many fantasy stories and role-playing games, players encounter an item, often a phoenix down or phoenix feather, which has a miraculous power. It is used to bring a fallen companion back to life, to snatch them from the brink of defeat. This powerful idea is a direct echo of the ancient myth of the phoenix. The bird's defining characteristic was not its fiery death, but its inevitable resurrection. It was the ultimate symbol of life's triumph over finality. By being consumed in its own sacred fire, it achieved renewal, returning from its ashes as a new, young creature. The phoenix down in these games is a symbolic piece of that very power, a feather from the bird that mastered death. It represents hope, resilience, and the belief that even from a state of total loss, life can be restored. It is a beautiful piece of modern folklore, a fragment of an ancient legend that continues to speak to our deep desire for a second chance. Fireflies create their light so efficiently that they produce almost no wasted heat. The light from a firefly, flashing in the warm twilight of a summer evening, is a marvel of biological engineering. We call it cold light for a very specific reason. An old-fashioned incandescent light bulb is incredibly inefficient. It works by heating a filament until it glows white hot. Over 90% of the energy it uses is wasted, radiated away as heat, not light. This is why a light bulb is hot to the touch. The firefly, however, has mastered a different process. Its light is the product of a chemical reaction, not a thermal one. Inside its lantern, an enzyme called luciferase mixes with a molecule called luciferin. This reaction, fueled by oxygen and the cell's energy, releases a photon of light. It is an almost perfect conversion of chemical energy to light energy. There is no heated filament, no wasted thermal radiation. The firefly's light is a pure, clean, and silent glow, a testament to nature's ability to create a gentle, perfect illumination that does not burn. The word bonfire may originate from the term bone fire, a large pyre used to burn animal bones. The bonfires we know today are for celebration, a gathering place of warmth and community, often lit to mark a festival or holiday. But the origin of the word hints at a much older, more primal purpose. In ancient pagan traditions, particularly Celtic festivals like Samhain or Beltane, large public fires were a central part of the ritual. These fires were seen as cleansing and protective. It is widely believed that the term bonfire is a direct descendant of the Middle English bone fire, meaning a fire of bones. In these rituals, the bones of sacrificed or slaughtered livestock were cast into the flames. This may have been done as an offering to the gods, or as a way to dispose of the remains after a great feast. Over time, as these rituals faded, the name remained, but its meaning softened. The bone fire became the bonfire, its ancient, solemn purpose slowly forgotten, leaving only the communal joy of the great, leaping flames. Volcanic lightning is a spectacular phenomenon that occurs within the ash cloud of an erupting volcano. When a volcano erupts violently, it does not just spew lava. It ejects a towering column of rock, ash, and gas high into the atmosphere. This dense, turbulent cloud is a place of immense static electricity as the tiny particles of rock and ash are blasted from the volcano. They rub against each. This friction strips electrons from some particles and adds them to others, creating a massive separation of positive and negative charges within the cloud, just like a thunderhead. The electrical potential builds until it becomes too great for the air to insulate. The result is a dramatic, powerful lightning strike that flashes within the ash plume itself. It is a stunning, otherworldly sight, a dirty thunderstorm where fire and ice collide. This is the Earth's raw power on display, a moment where the planet simultaneously creates a fire from its depths and a storm in the sky, all in a single majestic event. A backfire is a fire that is intentionally set to burn against an advancing wildfire. When a massive wildfire is moving across a landscape, driven by wind, firefighters sometimes face a force that is too large to confront directly. They cannot simply spray it with water. So they turn to a tactic that seems counterintuitive. They fight the fire with fire. A backfire is a carefully controlled fire, lit by firefighters, that burns in the direction of the main blaze. The goal is to create a black line, a wide, burnt-out area that contains no fuel. When the massive wildfire front reaches this barrier, it finds nothing left to consume. It is starved of its fuel, and, with nowhere to go, its advance is halted. This is a strategic, calculated risk, requiring deep knowledge of wind and terrain. The firefighters are not attacking the fire's front, but rather they are patiently and intelligently removing its future. It is a form of managed retreat, a way of drawing a line on the earth and telling the great fire, you may come this far and no further. The flashpoint of a liquid is the lowest temperature at which it will give off enough vapor to ignite with a spark. Every flammable liquid, like gasoline or alcohol, is in a state of constant, slow evaporation. It is patiently releasing invisible, flammable vapors into the air. The flashpoint is a precise measurement of this hidden danger. It is not the temperature at which the liquid itself will catch fire, but rather the temperature at which the air just above the liquid becomes a flammable mixture. At this exact temperature, the liquid is evaporating just enough that if a small spark or flame is introduced, the vapors will ignite in a sudden, brief flash and then go out. If the liquid is heated further, it will reach its fire point, where it will continue to burn steadily. Understanding this property is critical for safety. It is the invisible boundary, the precise moment in temperature where a liquid transitions from being stable to being a potential hazard, a quiet threshold where the air itself learns how to burn. In 1776, an American inventor created a perpetual candle that was designed to be self-extinguishing and relighting. Benjamin Franklin was a man fascinated by practical science and efficiency. He observed that when people fell asleep while reading, their candles would often burn down completely, wasting wax or worse, creating a fire hazard. He sought an elegant solution. His invention was a candlestick that held two candles, side by side, connected by a thread. The first candle, the main one, would burn as normal, but as it burned down, it would eventually ignite the thread. This thread was attached to a spring-loaded metal snuffer, a small cap. When the thread burned through, it released the snuffer, which would quickly snap down onto the second candle's wick, extinguishing it. The design seems to have been misremembered over time as a perpetual candle, but its true genius was the opposite. It was a self-timing candle, a clever mechanical device designed to save a bit of wax and provide a measure of safety, a small but thoughtful invention for a reader in the quiet hours of the night. The hottest part of a common candle flame is the blue glowing area at its base. When we look at a candle, our eyes are drawn to the bright, luminous yellow part of the flame. This is where most of the light comes from. But this part, while bright, is not the hottest. It is yellow because it is full of tiny glowing particles of soot or unburned carbon, which are releasing light through incandescence. The true heart of the fire's heat is in a different, much quieter place. Just above the wick, at the very base of the flame, there is a thin, almost invisible blue layer. This is where the wax vapor first mixes with the fresh oxygen from the air. In this zone, the combustion is nearly perfect and complete. There is very little soot, which is why it glows blue and is not as bright. This is where the temperature is highest, reaching up to 2,600 degrees Fahrenheit or 1,400 degrees Celsius. The familiar yellow flame we see is actually the cooler, less efficient part of the fire, floating gently above this intense, blue-hot engine of combustion. The chemical name for fire is not a single word, but rather the description of a process. Rapid oxidation. Fire, in all its majesty, eludes a simple chemical name because it is not a stable substance. It is a dynamic event, a cascade of reactions. The technical term for what we see is exothermic combustion, or more simply, rapid oxidation. Oxidation is the process of a substance reacting with oxygen. Exothermic means it releases energy in the form of heat and light. Rapid is what separates fire from its slower cousins, like rust or biological decay, which are also oxidation. When a log burns, the heat breaks down the wood structure, releasing flammable gases. These gases then mix with oxygen in the air, and if the temperature is high enough, they react. This reaction is a chain reaction, where the heat from one part of the reaction ignites the fuel next to it, creating the self-sustaining, visible, and hot event we call a flame. So fire's true name is not a noun, but a verb, a description of matter in a state of beautiful, energetic transformation. The smell of a campfire is a complex combination of hundreds of different chemical compounds. The scent of burning wood is one of the most evocative and ancient aromas known to humanity. It is a smell that is both comforting and wild, but it is not a single scent. It is a rich, airborne symphony. When wood burns, it does not just release carbon. The intense heat breaks down the complex organic molecules within the wood, like cellulose and lignin, into a huge variety of smaller, volatile compounds. These compounds are released into the smoke and carried to our nose. We are smelling phenols, which give a smoky, sharp aroma. We are smelling aldehydes and ketones, which add sweeter, pungent notes. We are smelling guaiacol, a compound that gives that classic smoky flavor. Each species of tree, whether pine, oak, or hickory, has a different chemical makeup and therefore releases its own unique perfume when it burns. That familiar, nostalgic smell is not one thing, but a cloud of hundreds of chemical stories, the fragrant memory of the tree's life. In Japan, some traditional festivals conclude with a Gozan no Okuribi, a ceremony of giant bonfires on mountains. Every August, during the Obon festival, a time when it is believed the spirits of ancestors return to visit their homes, the city of Kyoto performs a beautiful and solemn ceremony. This event, known as Gozan no Okuribi, or the Five Mountain Send-Off, is the act of guiding these spirits back to the spirit world on the mountainside surrounding the city. 5 massive bonfires are prepared. These are not simple piles of wood. They are carefully arranged into huge shapes, 3 in the form of giant Japanese kanji characters, and 2 in the shape of a torii gate and a boat. As night falls, these enormous bonfires are lit, one by one. They blaze in the darkness, some measuring hundreds of feet, or over 100 meters across. These great, silent emblems of fire are a beacon, a final warm farewell to the visiting spirits, a gentle and majestic light to guide them on their journey home, illuminating the entire valley with a sense of peace and remembrance. Fire breathing is a performance art that relies on a fine mist of fuel and a precise, gentle technique. It appears to be an act of magic, a human defying nature by breathing a plume of flame. But this dramatic display is an illusion, a careful manipulation of physics and chemistry. The performer does not have fire in their lungs. They hold a small amount of a specific fuel in their mouth, most commonly a highly refined, non-toxic lamp oil or paraffin. They then take a deep breath, hold a torch at arm's length, and forcefully spray this fuel out in a fine mist, like an atomizer. It is this fine mist, this aerosol, that ignites as it passes through the torch's flame. The secret is that the fuel must be vaporized. A stream of liquid would not ignite in the same way. The performer must control their breath, the angle of the spray, and the wind, all while ensuring no fuel drips or remains on their skin. It is an art of controlled risk, a beautiful, fleeting illusion that transforms the human breath for just a moment into a dragon's fire. The aurora borealis, or northern lights, is a form of fire in the sky, caused by particles from the sun. High in the polar skies, silent, magnificent curtains of green, red, and violet light dance and ripple. This is the aurora, a celestial fire that does not burn. It is a direct and beautiful connection between our planet and the sun. The sun is constantly breathing out a stream of charged particles, protons and electrons, known as the solar wind. When this wind reaches Earth, it is mostly deflected by our planet's magnetic field. But this field is weakest at the poles. There, the solar particles are guided down along the magnetic field lines, funneling into the upper atmosphere. As these high-energy particles strike the atoms and molecules of oxygen and nitrogen in our air, they excite them. They transfer their energy, and the atmospheric atoms release this excess energy as photons of light. The green and red glows come from oxygen, while the purples and blues are from nitrogen. The aurora is a cosmic light show, a gentle fire painted on the sky, the visible breath of the sun itself. In medieval warfare, Greek fire was a mysterious, incendiary weapon that could supposedly burn on water. For centuries, the Byzantine Empire held a terrifying secret, a weapon that saved their capital, Constantinople, from naval attacks time and again. They called it liquid fire. This substance, which we now call Greek fire, was a petroleum-based mixture that was projected from siphons mounted on the front of their ships. Its composition was a closely guarded state secret, and the exact formula has been lost to time. What made it so devastating was its unique and terrifying properties. It was said to be thick and sticky, clinging to ships and sailors. Most importantly, it could not be extinguished with water. In fact, water seemed to make it burn even more fiercely. It is believed to have contained naphtha, lime, sulfur, and possibly pine resin. The lime, reacting with water, would create heat, possibly reigniting the mixture. This weapon was a true fire of the sea, a substance that defied the rules, and a technological marvel that struck fear into the hearts of its enemies for generations. The word curfew has its origins in a medieval command to cover the fire. In the Middle Ages, towns were built of wood and thatch and were incredibly vulnerable to fire. A single stray ember from a banked hearth could doom an entire neighborhood. To prevent this, authorities enforced a strict rule. At a certain hour each evening, usually signaled by the ringing of a town bell, all citizens were required to extinguish their home fires for the night. The old French term for this was couvre-feu, which translates literally as cover fire. This was the act of covering the embers with a metal lid or damping them with ash to make them safe until morning. This command was not just for safety. It became a tool of social control, a signal that the streets were to be cleared. Over centuries, the original meaning was lost, but the word itself endured. Couvre-feu was adopted into English as curfew, transforming from a practical instruction about fire safety into a modern term for a time restriction, a quiet echo of a medieval bell ringing in the night. The practice of fire gazing has been a form of meditation for millennia, long before the word existed. There is a universal, unspoken draw to a flickering flame. We sit before a campfire or a fireplace, and our gaze softens. Time seems to slow, and the mind grows quiet. This is not a modern idea. It is one of humanity's most ancient and simple forms of contemplation. The fire offers something unique for the mind. It is constantly moving, yet it never goes anywhere. It is a dynamic stillness. This gentle, random, and non-threatening motion is captivating. It holds our attention without demanding effort, allowing the analytical, busy part of our brain to rest. Thoughts are allowed to come and go without judgment, much like the sparks rising from the embers. Before there were temples, before there were written philosophies, there was the hearth. Fire was our first source of warmth, light, and safety. In its glow, our ancestors found not only physical comfort, but a natural focal point for a quiet, reflective, and peaceful state of mind. A forest fire can burn so hot that it vitrifies the soil, turning sand into glass. The heat from a typical fire is immense, but an intense wildfire, especially one trapped in a gully or fanned by strong winds, can reach temperatures exceeding 3,600 degrees Fahrenheit or 2,000 degrees Celsius. This is hotter than the melting point of silica, the primary component of sand. When this happens, the fire ceases to just burn the surface. It begins to cook the earth itself. The intense heat penetrates the ground, melting the sand and mineral particles. As the fire moves on, this molten silica cools and solidifies, forming a glassy, non-porous crust called fulgurite, or, more broadly, vitrified soil. This strange dark glass is a permanent scar on the land. It prevents water from soaking into the ground and can stop new seeds from taking root, fundamentally altering the landscape for years to come. It is a rare and powerful testament to the sheer geological force of a fire at its most extreme, a moment when the flame becomes a sculptor of stone. The human body possesses its own fire, a slow, controlled combustion called metabolism. We often use the metaphor of burning calories, and this language is more literal than we realize. The fire that warms our bodies, powers our muscles, and fuels our thoughts is the same fundamental chemical process as a log burning in a fireplace: oxidation. But our bodies have mastered the art of cold fire. This process is called cellular respiration. Inside every cell, tiny structures called mitochondria take the fuel from our food, primarily glucose, and combine it with the oxygen we breathe. Instead of releasing all the energy at once in a destructive burst of heat and light, this reaction happens in dozens of tiny, carefully controlled steps. The energy is captured in a special molecule called ATP, which acts as the body's rechargeable battery. Our metabolism is therefore a quiet, invisible, and perfectly managed fire, a slow-burning flame of life that we sustain with every breath we take and every meal we eat. In 1911, the Triangle Shirtwaist Factory fire in New York City became a turning point for fire safety in America. The factory occupied the top floors of a tall building, crowded with immigrant workers, mostly young women. In the late afternoon, a fire broke out. The blaze spread rapidly, feeding on the flammable textiles. A terrible, tragic, and preventable disaster unfolded. The factory owners, fearing theft, had locked some of the exit doors. One of the main fire escapes was poorly built and collapsed under the weight of people trying to flee. The fire ladders of the time were not tall enough to reach the upper floors. In just 18 minutes, 146 workers died, many leaping from the windows to escape the flames. The profound public horror and outrage at this event became a powerful catalyst for change. In the years that followed, New York and the nation enacted a wave of new laws, mandating automatic sprinklers, proper fire exits, occupancy limits, and workplace safety standards. The fire's tragic, smoky legacy was the birth of the modern fire safety movement. Some species of fungi, known as pyrophilous fungi, will only fruit and release their spores after a forest fire. The forest floor, after a fire has passed, appears to be a sterile and lifeless place, a landscape of ash and charcoal. But for some forms of life, this is not an end. It is the perfect beginning. Certain species of fungi, like the black fire morel, lie dormant in the soil for years, patiently waiting. They cannot compete with the dense web of living roots and other soil life. The fire is their great liberator. The intense heat of the blaze destroys the competition, alters the soil's chemistry, and releases a wealth of nutrients. This is the precise signal the fungus has been waiting for. In the days and weeks after the fire, as if by magic, these fungi burst forth, carpeting the blackened ground in a sudden, abundant fruiting. They release their spores into the wind to settle on new ground, beginning the cycle anew. They are the first to rise from the ashes, a quiet fungal phoenix that reminds us that even in the bleakest landscape, new life is already preparing its return. The Ring of Fire is a 25,000-mile-long horseshoe-shaped path around the Pacific Ocean, where most of the world's volcanoes and earthquakes occur. This vast geological boundary is not a literal ring of burning fire, but rather a ring of potential, a place where the Earth's inner fire makes itself known. It traces the meeting point of several massive tectonic plates. These plates, which make up the Earth's crust, are in constant, slow-motion collision, as one plate, typically the dense oceanic crust, grinds against and slides under another, the continental crust. It is a process of immense friction. The descending plate heats up and releases water, causing the mantle above it to melt. This molten rock, or magma, is buoyant, and it rises to the surface, creating the great volcanic arcs that define the ring. This entire region, from the Andes of South America to the volcanoes of Japan and the mountains of New Zealand, is a testament to this deep, slow, and powerful process. It is the living, fiery seam of our planet, a place where the deep, creative fires of the Earth's core are constantly reshaping its surface. The bright, dancing flames we see are not the fire itself, but are actually composed of glowing, incandescent gases. When we look at a fire, it seems we are looking at the fire as a substance, but the flame is a visual effect, a visible marker of a process. The fire is the chemical reaction, but the flame is its light. As a log burns, for instance, the heat is not burning the solid wood. It is breaking the wood down through a process called pyrolysis, turning it into a cloud of flammable gases. It is these gases rising from the wood that are actually burning. As these hot gases rise and react with oxygen, they get so hot that they begin to glow, just as the filament in a light bulb glows when electricity passes through it. This is incandescence. The different colors, the yellows and oranges, are caused by tiny particles of soot or unburned carbon within this gas cloud, heating up and glowing brightly. The flame, then, is a river of rising incandescent gas, a luminous ghost of the fuel as it undergoes its final transformation into heat and light. In Norse mythology, the end of the world, Ragnarok, is foretold to be a time of fire and ice. The ancient Norse people envisioned a final epic battle that would bring about the end of their world and the death of their gods. This twilight of the gods would be preceded by a terrible, long winter. After this, the world's great conflicts would ignite. The fire giant Surtur, who had waited in the fiery realm of Muspelheim since the beginning of time, would finally lead his armies. He would march across Bifrost, the Rainbow Bridge, causing it to shatter. Surtur wielded a sword that burned brighter than the sun, and with it, he would set the 9 realms ablaze. The world tree, Yggdrasil, would tremble, and the entire earth would be consumed by this all-encompassing fire. Even the gods, like Odin and Thor, would fall in battle. But this was not seen as a final, absolute end. From this vast, cleansing fire, it was prophesied that a new, green, and beautiful world would eventually emerge from the sea, and a new generation of gods and surviving humans would inhabit it. The concept of a dragon's fire may have been inspired by real-world phenomena, like venomous spitting cobras or static electricity. The dragon is a universal myth, a powerful creature found in legends across the globe. One of its most defining and terrifying features is its ability to breathe fire. But where did this idea come from? Scholars have suggested it may be a mythic interpretation of very real and very frightening natural events. For example, a spitting cobra can project its venom over a distance, and this venom, if it enters the eyes, causes an intense burning pain. It is a fiery attack without flame. Others have noted that in dry, dusty caves, a large animal's movement could stir up flammable methane gas, which might be ignited by a spark of static electricity, creating a sudden, startling flash. To an ancient witness, such an event would be terrifying, a breath of fire from a cave's dark mouth. The myth of the dragon's fire is likely a tapestry, woven from these fragments of natural fear, combined with the awe-inspiring power of real fire and lightning. The fire piston insect, a tiny springtail, survives lethal cold by completely vitrifying or turning into a glass. Deep in the frozen soil of the Arctic, a tiny 6-legged creature performs a miracle of survival. The springtail is an ancient organism that faces temperatures of minus 90 degrees Fahrenheit or minus 68 degrees Celsius. At this temperature, the water inside an organism's cells would freeze, forming ice crystals that would shred the cell from within. The springtail has evolved a breathtaking defense. As the temperature drops, it floods its body with cryoprotectants, like tree halose, which is a sugar, and other proteins. This is a biological antifreeze. It does not stop the freezing, but rather controls it. Instead of forming sharp, destructive crystals, the water inside the springtail's body undergoes vitrification. It turns into a solid, but a non-crystalline, glassy solid, like amber. Its life processes stop. It becomes a tiny, frozen, inanimate glass statue. When the spring thaws, this glass melts, and the creature returns to life unharmed. It is a perfect, silent stillness, a victory over the cold. The great lighthouse of Alexandria, one of the wonders of the ancient world, used a fire and mirrors to guide ships. For centuries, this colossal tower stood watch over the harbour of Alexandria in Egypt. Built by the Ptolemaic kingdom around 280 BC, it was one of the tallest man-made structures of its time, standing well over 330 feet, or 100 meters, high. It was not just a monument. It was a practical, life-saving piece of technology. At its very top, a large fire was kept burning, day and night. This open flame served as a beacon. But to make it visible from far out at sea, it is said the lighthouse employed a massive, curved mirror. This mirror, perhaps made of polished bronze, would have captured the fire's diffuse light and focused it into a powerful, directed beam. This beam could be seen for dozens of miles, a guiding star on the horizon during the day, The same mirror was used to reflect the sun's light. The lighthouse was a masterful use of a simple fire, amplifying its gentle power into a signal that could conquer the horizon, a symbol of human ingenuity shining out over the sea. The Mimer Mounds of Washington State are mysterious, grassy bumps, whose origin was once attributed to ancient, smoldering fires. Across parts of North America, the landscape is covered in thousands of low, evenly spaced earthen mounds. For centuries, their origin was a profound puzzle. They are so uniform, they almost look man-made, yet they are clearly a natural feature. Early theories were imaginative. Some suggested they were ancient burial grounds. One long-standing idea was that they were the result of a vast, ancient, subterranean fire that smoldered through a peat-rich soil, causing the ground to heave and buckle in this strange, regular pattern. But the true answer, now widely accepted, is far more humble, yet just as amazing. The mounds are the work of generations of pocket gophers. For thousands of years, these small rodents have been tunneling, pushing soil, and building their nests over time. Their instinctual, repetitive behavior has slowly and patiently sculpted the entire landscape, pushing the rocky, less desirable soil into these regular piles. The mounds are not a scar of fire, but a testament to the power of small, persistent, living engineers. Firewalking is a practice that is possible not due to a high pain tolerance, but due to the poor conductivity of wood ash. The sight of someone walking barefoot across a bed of glowing red embers seems to defy human limits. It appears to be an act of supreme mental or spiritual control over pain and heat. But the secret to firewalking is not in the mind. It is in the physics of the materials. The glowing embers are made of wood, charcoal, and ash. While the embers themselves are indeed very hot, charcoal is a terrible conductor of heat. It is a fantastic insulator. It is full of air, and it does not transfer its heat energy very quickly. Furthermore, the walker's foot is only in contact with any given ember for a fraction of a second. There is simply not enough time for a dangerous amount of heat to be transferred from the poorly conducting embers into the skin of the foot. It is a beautiful demonstration of thermal physics, a trick where the properties of the material, not the willpower of the person, are the true marvel. The concept of a baptism by fire originally referred to a religious martyrdom, not a first-time experience. In modern language, we use the phrase baptism by fire to describe a difficult or challenging first introduction to a new job, task, or situation. It signifies learning under intense pressure. But the phrase has a much older, more somber, and more literal origin. It comes from Christian theology, where baptism is the rite of purification. While the first baptism is with water, a second baptism, or baptism of blood, was seen as the act of being martyred, of dying for one's faith. This was considered a supreme act of purification. The phrase baptism by fire is a direct reference to this, and to the words of John the Baptist in the Gospels, who said that while he baptized with water, another would come who would baptize with the Holy Spirit and with fire. The fire was a symbol of ultimate divine judgment and purification. Over time, this profound spiritual concept has softened, its fiery religious intensity repurposed into a secular metaphor for any difficult initiation. The will-o'-the-wisp is a folklore phenomenon of a ghostly, flickering light, which is likely the spontaneous ignition of marsh gases. For centuries, travelers have reported seeing strange, faint, and dancing lights hovering over bogs, marshes, and graveyards. These lights, which seemed to lead people astray, were given names like Ignis Fatuus, meaning foolish fire, or will-o'-the-wisp. They were believed to be the spirits of the dead, or mischievous fairies carrying lanterns. But science offers a quieter, more chemical explanation. Marshes are places of decay, as plants and animals decompose underwater. Without oxygen, they produce flammable gases, primarily methane and phosphine. It is believed that phosphine, which can have the property of self-igniting when it comes into contact with the air, provides the spark. This spark then ignites the methane, creating a brief, cool, flickering flame. This flame, with no real fuel source, would dance and move on the air currents, a truly foolish fire. It is a beautiful example of a myth born from a subtle, natural, and gentle chemical process, a real cold fire of the swamp. The burning of hell money, or joss paper, is a tradition in East Asian cultures to send goods to ancestors in the afterlife. In many East Asian traditions, the afterlife is seen as a place that mirrors the material world, a place where spirits have needs and desires. To care for their departed ancestors, the living perform a ritual of burning. They do not burn real currency, but rather a special symbolic joss paper or hell money. This hell is not a reference to a place of punishment, but a mistranslation, likely of the word for underworld. They also burn paper replicas of other useful items, such as houses, cars, clothes, and even phones. By burning these paper objects, the items are believed to be transformed and transferred to the spirit world, where the ancestor can use them. This act is not one of fear, but of profound filial piety, respect, and remembrance. It is a tangible way to continue to provide for and honor one's family, a fire that serves as a gentle doorway between the world of the living and the world of the spirits. Fire suppression on a massive scale only became possible with the invention of the standardized fire hydrant. In the 19th century, cities were growing rapidly, but firefighting was chaotic. When a fire broke out, firefighters would race to the scene, but finding a reliable source of water was a constant struggle. They often had to rely on cisterns, wells, or rivers, or break into the primitive wooden water mains, creating a wet geyser that was difficult to manage. The invention of the cast iron, above-ground fire hydrant, with its standardized connections, changed everything. This innovation, which became widespread in the late 1800s, meant that a pressurized, high-volume source of water was available on almost every city block. Firefighters could now arrive, quickly connect their steam-powered pumper engines, and deliver a powerful, consistent stream of water to the blaze. This humble cast-iron post, which we walk past every day, was a revolutionary piece of technology. It was the key that unlocked the city's own water system, transforming firefighting from a desperate bucket brigade into a modern, organized, and effective science. A firenado, or fire whirl, is a spinning vortex of flame that forms when intense heat and turbulent winds combine. This is one of nature's most dramatic and intimidating sights. It is not a true tornado, which descends from a cloud, but it has a similar terrifying beauty. A fire whirl is born on the ground, usually during an intense wildfire. It begins when a column of superheated air from the fire begins to rise rapidly. If the surrounding air currents are just right, different wind directions can cause this rising column to start rotating. As it spins, it tightens, like an ice skater pulling in their arms. This conservation of angular momentum causes it to spin faster and faster, sucking in more air, fuel, and embers. It becomes a self-sustaining vertical pillar of fire, which can be hundreds of feet tall and can have the rotational speed of a true tornado. These fire whirls are incredibly destructive, uprooting trees and throwing burning debris, a mesmerizing fiery spiral where the air itself has become part of the flame. The star Antares, in the constellation Scorpius, gets its name from an ancient Greek phrase meaning rival of Mars. Long ago, before the invention of telescopes, sky gazers charted the heavens with only their eyes. They noticed 5 wandering stars that moved against the fixed backdrop of the constellations. These were the planets. One of them, Mars, glowed with a distinct fiery and reddish hue and was named for the god of war. But the ancients also noticed that in the heart of the constellation of the Scorpion, there was a permanent fixed star that shone with the very same deep reddish color. This star was a giant, a red supergiant, one of the largest visible to the naked eye. Because its color and brightness so perfectly mimicked the planet Mars, it was seen as a competitor, a celestial twin. The Greeks named it Antares, which literally means not Mars or like Mars. Forever defining the star by its relationship to the red planet, it is a poetic name, a reminder of a time when the heavens were a story written in color and light. In 1871, the city of Peshtigo, Wisconsin, was consumed by a firestorm on the very same day as the Great Chicago Fire. The story of the Chicago Fire is famous, but on that exact same night, October 8th, a far more deadly and largely forgotten inferno was raging 250 miles, or 400 kilometers, to the north. Peshtigo was a logging town, surrounded by forests and built almost entirely of wood, including its streets, which were paved with sawdust. The region had suffered a severe drought, and many small fires had been burning in the woods. That night, a powerful cold front moved in, bringing cyclonic winds. These winds fanned the small fires into a single monstrous firestorm, a wall of flame over a mile wide and thousands of feet high. It moved at terrifying speed, creating its own weather. The heat was so intense it was said to have melted railroad cars. The firestorm completely incinerated the town of Peshtigo in about 1 hour. It burned 1.2 million acres, and, while the exact number is unknown, it is estimated that between 1,500 and 2,500 people perished, making it the deadliest wildfire in American history. The slow loris, a small primate, has a bite that mimics a fiery allergic reaction. This gentle, wide-eyed creature, which moves with a slow, deliberate grace, holds a surprising and fiery secret. It is one of the very few venomous mammals in the world. The loris has a special gland on the inside of its elbow that secretes a toxin. When threatened, it will lick this gland, mixing the toxin with its saliva. This mixture is not a poison that stops the heart or paralyzes the nerves. Instead, it seems designed to mimic a terrible burning allergy. When the loris bites a predator, this venom can induce a reaction that is similar to anaphylactic shock. It causes intense pain, swelling, and a feeling of burning heat. The predator's own immune system is, in effect, turned against itself in a fiery, agonizing response. This unique chemical fire is the slow loris's hidden defense, a powerful, venomous secret hidden behind its gentle appearance, a reminder that the natural world is full of surprising and inventive ways to protect itself. The sting of a fire ant is a fierce, burning pain, which is the result of a powerful, venomous alkaloid. When we think of this tiny red ant, we think of the fire in its name. This name is not just a reference to its color, but to the intense, fiery sensation of its sting. Unlike a bee's sting, which is acidic, the fire ant injects a complex venom. The primary component is an alkaloid called solanopsin. This substance is not a protein, but a lipid-like molecule that has a profound effect on our nerve cells. It mimics a body chemical that activates our pain receptors, essentially tricking our nervous system into feeling a hot, burning pain, as if it has been touched by a flame. This venom also has necrotoxic properties, meaning it kills the surrounding cells, which is what creates the characteristic white pustule that forms a day after the sting. This tiny creature carries a potent chemical fire, a sophisticated defense that burns with a heat far greater than its size would suggest. In Yazd, Iran, a Zoroastrian fire temple holds a sacred flame that has reportedly been burning for over 1,500 years. Zoroastrianism is one of the world's oldest monotheistic religions, and in its philosophy, fire is the ultimate symbol of purity, truth, and the divine. It is not worshipped as a god, but is revered as a living, visible representation of the Creator's light. In the city of Yazd, this reverence is given a timeless form. The temple's fire, called the Atashbaram, or victorious fire, is said to have been consecrated in the year 470. It is a flame that has been carefully and continuously tended by priests who feed it with dry wood, like apricot or almond. Several times a day, it has been moved, hidden, and protected through centuries of invasion and change, a living link to an ancient past. This flame is not a fire of destruction, but of endurance. It is a quiet, steady beacon, a testament to a faith that has patiently kept its light alive for over 15 centuries. The concept of spontaneous human combustion has haunted the public imagination, but it is not a scientifically recognized phenomenon. The stories are macabre and unsettling. A person is found, almost entirely reduced to ash, while the room around them, even the chair they were sitting in, is barely scorched. For centuries, this was attributed to an unknown internal fire, a spontaneous human combustion. But modern science has found a much quieter and more plausible explanation. This phenomenon is known as the wick effect. In nearly all recorded cases, the victim was elderly, infirm, and often near an external fire source, like a cigarette or a fireplace. It is believed an external flame first ignites the person's clothing. This clothing then acts as a wick. The body's own fat, melted by the heat, soaks into the wick and begins to burn at a low, steady temperature. Like a candle, which is designed to burn slowly for hours, this process can consume the body over a long period, producing a pile of ash while not being hot enough to ignite the rest of the room. In the mangrove forests of Southeast Asia, thousands of fireflies gather in a single tree to synchronize their flashes. While a lone firefly's flash is a small, quiet wonder, the sight of the Pteroptyx fireflies in Malaysia and Thailand is a spectacle of a different order. It is a symphony of light. As dusk falls, thousands of these male fireflies will settle in the leaves of a specific display tree. At first, their flashes are random, a glittering chaos of individual lights. But then, a rhythm begins to emerge. One small group will flash in time, then another and another. Over a period of hours, this synchrony spreads through the entire massive congregation until thousands of fireflies are blinking as one, a single pulsating beacon in the darkness. Scientists believe this is not a conscious collective decision, but a natural result of their internal clocks being influenced by their neighbors' flashes It is a breathtaking emergent phenomenon, a living constellation created from thousands of tiny individual fires, all learning to speak the same silent, rhythmic language. The strange glowing phenomenon known as St. Elmo's fire is not fire, but a form of plasma. Sailors on tall-masted ships, in the heart of a raging thunderstorm, would sometimes witness a ghostly blue-green light. It would appear on the tips of their masts, on the rigging, and even on their own fingertips. It did not burn, and it was often accompanied by a faint hissing or crackling sound. They called this St. Elmo's fire, naming it for their patron saint, and seeing it as a sign of his protection, a good omen in the storm. But this strange glow is a natural electrical phenomenon. It is a corona discharge, a form of plasma. In the intense electrical field of a thunderstorm, the air molecules themselves are torn apart. Electrons are stripped from their atoms, and as they recombine, they release this energy as a visible, cool light. It is the same principle as a neon sign. This is not a chemical fire. It is the air itself, excited by the storm's power, beginning to glow with a silent electrical flame. The vibrant, beautiful colors of fireworks are created by adding metallic salts to the explosive mixture. When we watch a fireworks display, we are seeing a masterful display of chemistry, a form of painting with fire. The bright flash and the loud bang come from the rapid combustion of a gunpowder-like mixture. But the colors are a separate, more subtle art. They come from simple metallic compounds, or salts, that are mixed into the explosive stars. Each metal, when it is vaporized at a high temperature, releases its energy in the form of light, and each metal has its own unique signature color. For a deep, vibrant red, pyrotechnicians use strontium salts. For a brilliant blue, they use copper compounds, which is the most difficult color to create. Barium salts burn with a steady green, and sodium, the same element as in common table salt, burns with that familiar, intense orange-yellow. The firework is a carefully wrapped recipe, a chemical packet designed to create a specific, beautiful, and fleeting moment of colored light against the night sky. In parts of Polynesia, a fire-walking ritual called the umuti involves walking on superheated volcanic stones, not embers. While many firewalking traditions use a bed of low-conductivity wood embers, the ritual practiced on islands like Fiji is a far more intense and mysterious ordeal. Here, the oven is a large pit filled with porous volcanic rocks. A massive fire is built on top, and it burns for 8 to 10 hours, heating the stones to an incredible temperature, estimated to be over 1,000 degrees Fahrenheit, or 530 degrees Celsius. These are not insulating embers. They are solid rocks, glowing hot. And yet, the participants walk across them, seemingly unharmed. The scientific explanation for this is still debated. Some believe it is the Leidenfrost effect, where the moisture on the walker's feet instantly vaporizes, creating a temporary insulating layer of steam. Others believe it is simply done very quickly, minimizing contact time. For the practitioners, however, it is a sacred spiritual test, a tradition where faith and fire meet. In the grasslands of northern Australia, certain birds of prey, like the black kite, have been observed intentionally spreading fires. The Aboriginal peoples of this region have long held traditional knowledge of these firehawks. They tell stories of birds picking up smoldering twigs or embers from one fire and dropping them in a new, unburned area. For a long time, this was dismissed as folklore. But in recent years, researchers have documented this behavior. They have observed black kites and brown falcons intentionally grasping burning sticks, flying with them for a short distance, and dropping them into a patch of dry grass, igniting a new fire front. The motive appears to be hunting. The new fire line flushes out small animals, insects, and lizards, which are then easily caught by the birds as they flee the flames. This is a staggering example of tool use in the animal kingdom, a complex cognitive leap, where the birds are not just adapting to fire, but actively and intelligently harnessing it as a tool. The visible surface of the sun is called the photosphere, which is a Greek word meaning sphere of light. This is the layer we see with our eyes, the brilliant golden disk that we call the sun, but this surface is not solid, like the ground on Earth. The sun is a ball of gas, or more accurately, plasma. The photosphere is simply a layer, about 300 miles, or 500 kilometers, thick, where the gas becomes so dense that it is opaque. It is the bottom of the sun's atmosphere, the boundary from which most of the sun's light finally escapes into space. Below this layer, the sun is a dense, churning fog of plasma, and we cannot see inside. Above it, the gas becomes thin and transparent, forming the corona. The photosphere itself is a roiling, boiling surface, covered in granules the size of Texas, which are the tops of hot, rising columns of gas. It is a magnificent, dynamic boundary, a glowing shell whose entire purpose is to radiate the fire of the sun's core into the cosmos. A foxfire is the name for the gentle, eerie, blue-green glow that is sometimes seen on rotting wood in a dark forest. Long before science understood the mechanism, people would be walking in a damp, dark forest at night and see a ghostly, cold light. It seemed to cling to dead, decaying logs, giving off an illumination that was just bright enough to read by. It was called foxfire, a name whose origin is uncertain, but it was often associated with the supernatural, with fairies or spirits. We now know that this light is a form of bioluminescence. It is the work of certain species of fungi, like the honey mushroom. As the fungus grows, its mycelium, the thread-like network of its body, digests the wood. As part of this metabolic chemical process, it releases a steady, continuous, cold light. The fungus is, in effect, burning the wood, but with a slow biological fire that releases light instead of heat. This silent, glowing wood is a beautiful reminder of the hidden chemical wonders that are always at work, even in the darkest, most quiet places. The first practical, self-igniting matches were called friction lights, and they were invented by John Walker in 1826. For all of human history, creating fire was a cumbersome process. It required friction drills, flint and steel, or a fire piston. A portable, instant fire was a fantasy. This changed with the work of an English chemist named John Walker. He was experimenting with different chemical mixtures that could ignite from a simple spark. He created small wooden splints tipped with a paste of potassium chlorate, antimony sulfide, and gum. When these sticks were scraped against a rough surface, like sandpaper, the friction was enough to ignite the chemical head, which in turn lit the wood. Walker called them friction lights and sold them from his pharmacy. They were not perfect. They were somewhat unreliable and had a strong, unpleasant smell, but they were a revolution. For the first time, a person could carry a small, reliable spark in their pocket. This simple chemical stick was the first step toward mastering on-demand fire, changing our relationship with light and warmth forever. The burning of the ancient Library of Alexandria represents a profound, symbolic loss of knowledge for the Western world. The Library of Alexandria was more than just a collection of scrolls. It was an institution, a center of scholarship, perhaps the single greatest intellectual hub of the ancient world. It was a place where scholars gathered to study, translate, and copy the accumulated knowledge of Greece, Egypt, Persia, and beyond. Its goal was to contain all of human knowing. The story of its burning is not a single dramatic event, as it is often portrayed. The library's decline happened over centuries. It suffered from neglect, purges of scholars, and several different documented fires, most notably during Julius Caesar's civil war. This gradual, slow destruction, this death by fire, both literal and metaphorical, has come to symbolize something deeply tragic. We imagine the loss of unknown plays, lost philosophies, and forgotten histories, all turned to ash. The fire of Alexandria is a powerful, enduring metaphor for the fragility of human knowledge and the way a civilization's memory can be erased by the flames of conflict and time. The oak savanna ecosystems of North America are not true forests and not true prairies, but a park-like landscape maintained by fire. When European settlers first moved into the American Midwest, they did not find a dense, dark forest. They found a landscape that amazed them. It was a sea of tall grasses and wildflowers, dotted with large, magnificent oak trees. These oaks, like bur oaks, stood far apart, their wide, gnarled branches creating a beautiful, open canopy. This savanna was a man-made, or rather, a fire-made, landscape. It was the result of millennia of frequent, low-intensity ground fires, many set by Native American communities. These fires would sweep through the grasses, killing off the brush and the saplings of other trees that could not tolerate the heat. But the mature oaks, with their incredibly thick, corky and fire-resistant bark, were left unharmed. The fire was a selective gardener, clearing the understory, renewing the grasses, and ensuring that only the strongest, most resilient trees would define this open, sun-dappled world. While many cultures associate the afterlife with fire, the ancient Norse underworld, hell, was a place of bitter cold. In the Christian and Islamic traditions, the place of punishment, hell, is vividly imagined as an eternal fire, a place of burning and torment. But this is not a universal vision. For the ancient Norse peoples, the Vikings, life was a struggle against the harsh, unforgiving northern winters. To them, warmth, the campfire, and the hearth were symbols of life, community, and comfort. The greatest terror, therefore, was not fire, but its absolute absence. Their underworld, hell, or Helheim, was not a fiery pit. It was a dark, damp, and freezing cold realm, a place of mist and ice, ruled by a goddess of the same name. It was here that those who did not die a glorious death in battle went. This vision of the afterlife is a powerful reflection of a culture's greatest fears for a people huddled against the cold. The most profound punishment was not a burn, but an eternal, unending winter. The roaring of a large fire is the sound of a massive, sudden expansion of air. A small campfire crackles from the steam escaping the wood, but a great, raging fire has a different voice. It roars. This deep, intimidating sound is not the sound of the fuel. It is the sound of the air itself being violently consumed and expanded. A large fire is an engine of immense heat, and it creates a powerful chimney effect, known as an indraft. It pulls in huge volumes of cool air from all sides, and as this air hits the flame, it is superheated in an instant. This sudden, explosive expansion creates a powerful pressure wave, a shock wave that our ears interpret as a deep, booming or roaring sound. The fire's roar is the sound of a continuous, rapid explosion. It is the audible evidence of the sheer volume of the atmosphere being displaced by the fire's thermal power. It is the voice of the fire's own immense, invisible breath. The cork oak tree, which grows in the Mediterranean, has evolved a thick, spongy bark that allows it to survive frequent forest fires. In the hot, dry climates of Spain and Portugal, fires are a common, natural part of the ecosystem. Many trees perish, but the cork oak has mastered a strategy of defense. Its survival is owed to its bark. This bark, which is the same material we use for wine corks and bulletin boards, is a unique natural insulator. It is composed of billions of tiny, air-filled, waterproof cells. This structure makes it incredibly light, buoyant, and most importantly, highly resistant to heat. When a wildfire sweeps through a cork forest, the flames may char the outside of this thick, protective layer, but the intense heat cannot easily penetrate. The air trapped in the bark cells acts as a perfect thermal shield, protecting the living, sensitive tissues of the tree's trunk, hidden deep inside. After the fire has passed, the cork oak is often able to sprout new leaves and continue its life, a silent, fireproof guardian of the forest. The guy in Guy Fawkes' Night is the same root word as the guy rope of a tent, and it is unrelated to bonfire. Every November 5th in Great Britain, people light bonfires and burn an effigy, a guy, to commemorate the failure of the gunpowder plot of 1605. The plot was led by Robert Catesby, but the man caught guarding the explosives was named Guy Fawkes. He became the face of the plot. On that night, people began lighting bonfires in celebration of the king's safety. They soon began burning effigies of the Guy Fawkes. Over time, the word Guy transformed. In the 19th century, in America, it evolved to mean any strangely or shabbily dressed man. Like the effigies, from there, it slowly softened further into a generic, informal term for any man. So when we use the word guy today, we are unknowingly referencing the effigy of a 17th century conspirator who was burned on a bonfire, a word which, as we know, may itself mean bonefire. The ancient eternal flame at Delphi, which burned at the oracle, was likely a natural gas vent. For centuries, the Oracle of Delphi was the most powerful and revered institution in the ancient Greek world. A priestess, the Pythia, would sit upon a tripod in the inner sanctum of the temple of Apollo. She would breathe in the sacred vapors that rose from a fissure in the earth, and in her resulting trance, she would speak the words of the god. An eternal flame, the Ner Tamid of the temple, also burned nearby. For a long time, scholars dismissed these vapors as myth, but recent geological surveys have revealed that the temple was, in fact, built directly over two intersecting fault lines. It is highly probable that these fissures released light, hydrocarbon gases like ethylene, which has a sweet smell and can induce a disoriented, euphoric state. The sacred eternal flame was likely this same natural gas vent, which, once lit, would burn steadily, a truly eternal fire fed by the Earth's own slow chemical breath. Before the modern theory of combustion, scientists believed fire was the release of a substance called phlogiston. For most of the 18th century, the scientific world was dominated by a beautifully simple but incorrect idea. This was the phlogiston theory. It proposed that all combustible materials contained a hidden, fire-like element called phlogiston, named from a Greek word meaning to set on fire. When something burned, it was not combining with oxygen. It was releasing its phlogiston into the air. A log, for example, was seen as a combination of ash and phlogiston. When it burned, the phlogiston escaped, leaving only the ash behind. This theory explained many things. It explained why things stopped burning in a sealed jar. The air had become full of phlogiston. But it had one great flaw. When metals were burned, they gained weight, which they should not have if they were losing a substance. This single, awkward fact eventually led to the theory's downfall, making way for Antoine Lavoisier's discovery of oxygen, which finally and correctly identified fire as a process of combination, not release. A fire breathes in a continuous steady cycle of indraft and updraft. A fire is not just a hot object. It is a dynamic, living system that actively interacts with the air around it. It has a respiration of its own. The intense heat of the flames creates a column of rising hot air and smoke. This is the updraft, or the fire's exhalation. As this hot, light air rises, it leaves behind a low-pressure area at the base of the fire, a vacuum. The surrounding cooler and heavier air, which is rich in oxygen, is then pulled in to fill this void. This is the indraft, the fire's inhalation. This new, fresh supply of oxygen then feeds the flames, making them burn hotter, which in turn strengthens the updraft, which then strengthens the indraft. This creates a powerful, self-sustaining loop. A large fire is a powerful breathing engine, inhaling the cool air of its surroundings and exhaling a great column of heat, its breath shaping the very winds around it. And so, our journey through the glowing world of fire comes to a gentle close. We have sat with this ancient companion, from the tiny spherical flame in space to the vast self-made weather of a wildfire. We have seen it as a tool, a sacred symbol, a chemical dance, and a quiet biological warmth. Fire is not a thing, but an event. It is the story of release, the transformation of matter into memory, whether in the bright, sudden flash of a firework, or the slow, patient rust on a piece of iron. It is the engine of our sun and the quiet, cold light of a firefly. It is a force that seems so powerful, yet it is born from a fragile triangle of needs. It is the gentle gardener of the forest, the destroyer of cities, and the spark of inspiration from the roar of a firenado to the silent, ghostly glow of foxfire on a forest floor. It has always held our gaze, inviting us to be quiet, to be warm, and to wonder. The flame is a fleeting, beautiful, and eternal story, and tonight we have read a few of its quiet chapters. If you happen to still be awake, that's perfectly all right. You can simply lie back, let the music keep flowing in the background, and drift in and out of the story at your own pace. But if your eyes are heavy, let the stories of fire and the gentle music carry you softly into rest. Sleep well. Good night.